Okay, so I have been given very strict instructions about making sure we start everything on time today, which is uncharacteristic. So we're going to get rolling. If you're still filing in, either there's a couple seats in the middle, or you can just kind of hang out on the sides. So I'm going to rock on really quickly here because I have a very special guest speaker with me today, so I am sharing the spotlight. If you don't know, this is the deep dive on microservices and ECS. If you didn't mean to be here, I'm really sorry, but I don't know how you'll get out. So now you're stuck with me. Cool. So whenever I learn how to use a clicker. Agenda, as always, as promised. So we're going to cover a couple of things. So what are microservices? We're going to do a lightning ECS overview. We're going to get feature specific. We're going to talk about flexible container orchestration in ECS. We'll talk about container lifecycles with the ECS CLI. And then we will talk about our customer use case with our special guest star from CloudLock. We have really limited time, by the way, so if you have questions, if you can, please save them for the end, and I will hang out afterwards and talk with you guys as long as you want. So what are microservices? So this is our favorite definition. It comes from Adrian, who gave the keynote this morning, and we used to call him the best evangelist that doesn't work for AWS, but now he works for AWS. So the joke isn't as funny, but so our definition here, a service-oriented architecture composed of loosely coupled elements that have bounded context. And that's a really fancy way of saying here that when we're making our microservices, everything should have a specific piece. It should have a very separate and specific context, and it should communicate with the other services only over the network. So you write your service, it has a specific purpose in mind, and when it speaks to another service, it only goes over the network. They're not kind of interconnected, so they should be atomic pieces. So why is this important? So we've seen this diagram a lot in various kinds of iterations, and when you're moving from your big monolith to your little microservices, how do you do this? And kind of the monolith way of looking at things is I have one big piece, everything is together, and it might have lots of different functions, but they are all one service. And when you break that out, you have to figure out, okay, so what goes from this monolith to my microservices? So all those different functions, all those different jobs that make up your monolith get separated out into those small microservices. And those should have a very specific purpose, and they should communicate with each other over the network, so a public API. There are some characteristics of this microservice architecture once you've decomposed your monolith. So it's decentralized, can be whatever language you want, and you should use the tool that fits the job that you want. So just because you have one service that's in Node.js shouldn't mean that you can't have another service in Ruby. It should have one purpose. So if you find your microservice has many purposes, perhaps you need many microservices. You build it, you run it. So we used to talk about when you had DevOps, so this is the DevOps and automation track. We used to talk kind of about DevOps, you'd throw your stuff over the wall. So if I was a developer, I'd write my service, I might write tests if I was a kind and generous developer, but it was someone else's problem when it came to deploying it and kind of getting that on production. And with microservices, for a lot of people, that's really different now. So I build it, I run it. So I'm responsible both for writing the service, for deploying it, for writing those tests. Independent, black box, same things as we just talked about with Adrian's definition. Make sure it has a job, make sure that it's decoupled from all my other services, and make sure that it's only doing its one job. So how do we do this? How do we work with these microservices effectively on AWS? And for a lot of people, that's where ECS comes in. So ECS is Amazon's EC2 container service. So highly scalable, high performance container management system. So if I'm writing these microservices, I'm writing them in containers. So each service is its own container. And EC2 eliminates the need to install, operate, and scale kind of my own container infrastructure. So what does that mean in more kind of plain words? So a couple of things. We have three characteristics. We have deep AWS integration, we get container orchestration, and we have cluster management. So rather than having to write a bunch of tooling to manage all of these containers ourselves, because you get a lot of overhead, right? So if you go from managing just your single monolith to running 30 microservices, there's a lot more work that goes into kind of orchestrating, scaling, deploying those services, and that's where ECS comes in. So I added this slide really recently because I started getting a lot of questions that sounded very similar to each other, and that was, okay, but how does ECS kind of tie back to things that I'm familiar with. So I made this diagram. I made it in Word. Like all my diagrams, it is not very pretty, but it gets the point across. So an instance, that is a standard EC2 box. Once you've registered it to your ECS cluster, your tasks run here. A service is a layer that manages and places tasks on those instances. And a task is a container wrapper and configuration around processes that are running on that instance. So that's it. It's not kind of as vague as it sounds, right? So all of the pieces that make up ECS map back to very traditional EC2 concepts. You're just doing it at the container level now rather than just the server level. So who's using ECS? This is my fun shout out board. I can't fit any more logos on here, but there are many more. That purple airtime logo was me also. I was one of the first beta testers of ECS, which is why I'm always talking about it. Lots of people using it, lots of people doing really cool things, building tooling around it, so check some of those out. Why are these people using ECS in the first place? So why is this a solution that people are kind of using to manage their containers? And the big thing for most people is fully managed. So it's already tied to AWS. It's really easy, and that was why I went with it in the first place also, so I had a big project. I had a monolith, and I wanted a bunch of microservices. And the easiest way for me to kind of make that transition was by using something that felt really close to what I was already using. Lots of cool scheduling stuff. And then there's a bunch of different tracks going on today. There's a bunch of different sessions, and a lot of them are talking about other AWS tools. So I know that Tara spoke 2 sessions ago about some CodeStar things. These are all tied with ECS also. So if you're using ECS, it's really easy to integrate that with other AWS services. We talked about some scheduling goodness. One of the cool things about containers is that you can use them for a bunch of different purposes. So I can run a task just once. I can schedule my task to run like a cron job and run it on that same cluster infrastructure. I can use start task. I can scale them up and down. I can have my normal kind of long running jobs. You can use kind of that same infrastructure and the same container format in a bunch of different ways to do a bunch of different types of jobs. So you can schedule them your own way. You can write your own scheduler. You can schedule batch jobs. You can schedule the long running ones. But you can use that same infrastructure to do a bunch of different kinds of tasks, which I think is really helpful, right? So previously, if you were kind of running your one big app and you ran it on one host, and then you couldn't really do much with the rest of that infrastructure. And now you can kind of use the leftover pieces of that infrastructure to run other tasks on as well. So let's get feature specific. There's a bunch of different features. We're just going to cover a couple of them really quickly, and then we'll do something cooler. So task placement. So I promise that you could use your resources efficiently. So how do I actually make that happen? So you're able to customize this now. So a task placement strategy is what lets you select the instance that you want to place your task on. And you can use constraints on top of that to kind of determine at a more granular level where that task goes. So you use those together, and you can determine where you place your tasks. So how does this work? Here's a couple of characteristics. So you could do them from AMI or availability zone or your instance types, or you could do custom. So if you had one cluster and you wanted to deploy some things to, you called staging instances, and some things to prod instances, you could do that with a constraint. Multiple strategies, I'll explain these. So binpacking is basically use your resources as efficiently as possible. So if I have 2 hosts, and one of them has 4 tasks running and has just a little bit of CPU and memory left, and I have one host that has like almost nothing on it, if I binpack, I'll use up all the resources on that first box before I go to the second one. So I can have the least number of hosts running as possible. Random is just what it sounds like. It's random. And spread means that you can distribute them evenly throughout groups of instances. So for example, by availability zone. So how does this actually work? It's basically, it's an order of operations, just like middle school math class. Turns out I'm a bad Amazon citizen and don't install my updates. Boo, exactly. I did. Don't tell anyone that I did that. We'll go back. Ready, ready. Oh, shoot. No. It's okay. All is well. Okay. So we're back on my middle school math class flowchart. So we can do our order of operations here. So we start off and say, okay, here are my basic requirements. So in order to place a task, I have to have the resources to support it. So I need to have my CPU, I need to have my memory, and we need to have the port open. On top of that, I can do my custom constraints. So for example, is this the instance type that I want? On top of that, I can do my strategies. So am I using my resources as efficiently as possible, or am I trying to spread them out? And then finally, apply all these filters and select the instance that I want to place my task on. Second one, and there's a theme to all of these, and if you can guess it, you win a prize. It's a sticker. But I'll tell you anyway. So second feature, event stream for CloudWatch. So I was talking to someone about this in the hallway, but ECS admits events. And previously, you kind of had those events, and you could use them within ECS, or if you knew the right API call. And now you can emit them and you can consume them with CloudWatch. So on top of that, and it sounds like, okay, well, events. So I start tasks and whatever, and that's cool, but I already knew that I started it. But what's cool is that on top of that, you can build things with those events that consume those events. So you could build a custom scheduler, or you could monitor something like cluster state, and then you could use them with other services. So everyone's favorite, which is Lambda. So you can use those events to do other things that you want. So customize, extend, change things the way that you want to, but you can emit your own cluster events and consume those with other services. So flexible orchestration in ECS. So I promised a theme, and the theme here I think is really flexibility. So what I'm looking for when I pick an orchestration platform is that my platform should have both sensible defaults and the ability to extend and customize. So what does that mean? So it means that when I start off, I should be able to use the defaults that a service has out of the box. So I should expect that ECS will not steer me wildly in the wrong direction for how much memory a service should use, but that I should also be able to extend and customize on top of that. So I should be able to change things, I should be able to build my own logic, I should be able to consume events, and I should be able to pick and choose a combination of one or both of those. So first off, with ECS, we have options. So if I don't touch anything, this is fine. It'll help me start my task. It will give me some fairly sensible CPU and memory defaults. I don't have to do anything. If I want to do something, I can, but it will help me kind of get started as seamlessly as possible. We're going to do a little fake demo, and the fake demo is because I don't have internet, and so I made it up. So we're doing a fake demo, but spoiler alert, I'm possibly the only person that likes the console, but why? So you'll look at my reasons. Reason number one is JSON. Have you tried making a VPC with JSON from the CLI? If you've tried to do it, don't ever again. So first reason, JSON. So it's quicker to test, it's quicker to get started. I get visual feedback. So if I do something with my cluster in the console, I can see the result. It comes right back at me, and I can see what's happening. My fourth reason is also JSON. If I were to make a list of 10 reasons, 9 of them would be JSON. It's mathematically wrong, yeah, well, all JSON. You can blame JSON. But the console is not for everyone. So if you're automating, if you're customizing, the CLI is probably a better choice. So there's some tools out there for ECS to use with the CLI. There's actually two. This is the one that I prefer to use, but basically you can manage your container life cycles from start to finish without using the console. So let's look at my fake demo. So what does this look like? So we're going to walk through a really easy version of what it looks like to kind of work with the ECS CLI. So I create my cluster. It's called Summit. Returns me some status info. Then I have to create a task. So I can do this by using a JSON string, or I can pass it a file that I wrote in my text editor and used a linter on. So either way, I can pass it the parameters with how I want to start up my task definition, and I'm going to need my task definition a little bit later when I start my service. So I'm using it right now. Here's where we use the things like the placement strategies that we looked at before. I create my service, I say how many copies I want running, and I can add my parameters and I can register my service with an ELB or ALB. So what happens if I want to scale my service up? So we probably can't just have a static service. I can change my desired count. I can use the reverse of this to scale my service back down, which we'll look at. But this is also effectively a deployment. So if I change the task definition that I'm sending, that's a deployment. So if you think about it, you might be automating that a little bit later, but by changing that task definition, by changing that revision, I'm sending a new copy, which means that I have a couple of things. So I have version control of my task definitions, and then I also have version control. If I've done that through a CI/CD system, I can tie that back to a build. I can tie that back to the commit that triggered the build in my continuous integration system. So I'm going from the commit that I made locally, that I pushed to a branch, that triggered a build, that passed a new task revision to ECS, that was deployed. So I can look at those pieces all the way back, and I can see, okay, well, here's the commit that went to that service that did that thing. So if my service breaks right after it, it's really easy to debug, right? Because I know the exact commit that set that off. You can do some other cool stuff here. So we can query state. You could use these messages. You could use these events. You could consume them with other services. You could do cool stuff with it. For the purposes of this demo, I have done nothing cool. My service is flawless. By Tel Aviv. So I'm closing down my cluster afterwards. We talked a little bit about the scaling, but the important thing to look at here that I've gotten a couple times is that if I scale something up, I got to scale back down again. So I'm cheap, and I don't like to pay for extra infrastructure that I'm not using. So if you have a scaling event, which you can do kind of automatically through ECS, if I write a scaling event to scale my messaging service, my summit service, in response to like an alarm, I want to make sure that I scale back down also. Otherwise, you've scaled up to have a bunch of extra capacity that you don't need once you don't have the traffic for it. And without further ado, I have a very special guest. Please welcome David from CloudWatch Logs. This is yours. Just click that.
Thank you, Abby.
Yeah.
Thank you, Abby. Hello, everyone. I'm David Melamed, and one sec. I'm trying to find the red button. This one. Okay. Hello, everyone. I'm glad to be here. And I'm here to actually share with you our experience regarding running microservices in ECS and Docker. But before I start, I would like to share a few words about my background. I have a PhD in bioinformatics. I'm a tech leader in the cyber intelligence team in Cisco CloudLock, a cybersecurity company that was acquired a couple of months ago by Cisco. And I'm passionate with technology. In particular, everything that touches containers and serverless. Generally speaking, the emergence of the cloud has brought various challenges to the IT world. While traditional companies are still running on-premise, our customers are running either 100% in the cloud or a mix of both, leading to hybrid environments. And to tackle this situation, Cisco came up with the idea of the Cloud Center, which is an application-centric cloud platform management system that is designed to handle those complex applications across various infrastructures like data centers, private or public clouds. And in addition, it also gives you a single pane of glass visibility and control across all the IT services. But let's focus more on the cloud. By 2018, Gartner predicts that an average company will have 25% of its traffic bypassing network, which means that if you only rely on the perimeter security, then you will be only protected at 75% at best. And that's where Cisco CloudLock comes into play. Cisco CloudLock is 100% cloud native, running on top of AWS. No agents, no proxy needed. We only work with APIs, both internally and as a way to connect to our customers' cloud applications. In our platform, we have two main areas, where first of all, we're CASB for SaaS, where we protect business apps in the cloud. But we're also unique in the industry by extending our security controls for applications that are running on top of IaaS and PaaS. So for example, if I'm deploying an application that is running on Amazon, and I want to enforce HIPAA compliance because I'm working in the healthcare market, then I can use Cisco CloudLock with their DLP microservice that has the ability to scan and detect sensitive content in S3 buckets. More generally, we're here to ensure three main use cases. First of all, users, where we continuously monitoring for compromised accounts and inside the threat. For example, here you can see that there are two logins that are separated by 1 hour in time, but thousands of kilometers in distance, which may clearly indicate a threat. Data is a second use case, and beyond just monitoring for compliance violations, we're also giving ways of remediation, as well as protecting the critical assets and making sure that they are not overshared. And finally, apps, where we give visibility and control. Visibility into auth apps is as critical as understanding the access scopes that were granted to the applications in the first place in order to detect malicious behavior and be able to revoke those applications. In terms of infrastructure, we have different type of units. First of all, microservices. They're running on top of ECS, RDS for databases, ALB and ELB, and Route 53 to route and balance the traffic. We also have workers that are leveraging Kafka to stream the customer events, as well as a bunch of EC2 instances in order to process them. And finally, we're investing a lot in data analytics in order to be able to detect malicious behavior. And we're using a combination of S3, Lambda, EMR Spark, and Elasticsearch for the analytics. In terms of scale, we're running dozens of microservices in multiple environments and regions also. We also are scanning millions of customer documents, and we're processing billions of events from SaaS providers. We're also a Python shop. We love Python. It's flexible. Its ecosystem is really great. And we recently moved to use Terraform to manage our stack. Now, let me give you an example of a great integration of various services that we leverage to build a full workflow for our cyber analysts. So here you can see that they're running. The use case is actually to create an assessment report for our customers. They will be able to deliver. So here you can see that they're using Slack command to send a request to the API gateway, which is forwarding that to a Lambda, who is creating an EMR Spark instance, running a bunch of EMR steps, which is producing the reports, whose URL is finally posted back to a private Slack channel. And now I want to give you 10 advantages of running microservices on production with ECS. The first one is the support for a private Docker repository. This allows us to integrate ECR into our CI pipeline very smoothly. And as you can see here, upon a git commit or a push on a deity button, we're triggering Jenkins' job that is building a Docker image, pushing it to ECR, and then it's used by a bunch of ECS containers. The second use case and the second advantage is using CloudWatch, integration of CloudWatch. First of all, it's a great way to centralize all the logs with a simple configuration and task definition. So you just need to put your log driver as AWS logs, and then every log is pushed to CloudWatch Logs. Alarms are a really great way to monitor your system, and if you create an alarm for unhealthy services, you can trigger an SNS notification and then trigger a Lambda that will run your custom code in order to remediate with the situation. The third advantage is the ability to run long-running recurring tasks. So sometimes you have small tasks that are less than 5 minutes. For example, deleting a bunch of old indices in Elasticsearch. And sometimes you have longer tasks. For example, restoring a database dump. So for the first one, you have a great system called Lambda, and very easily you can write some code deleting this, connect that to CloudWatch Event, and you're good. But if you have a longer task, then you cannot do that. So the convenient way we actually leverage here is a combination of a CloudWatch rule in order to trigger the task daily. CloudWatch is triggering a Lambda, and the Lambda is spinning up an ECS one-time container using run task in order to restore database. And the container is killed automatically at the end of the task. Fourth, running update or blue-green deployment. Who doesn't like zero downtime deployment? So here you have two choices. You can either use the system that is built in ECS service, which is called running update, and you need only to define the number of tasks that you want to keep alive when you're deploying a new version. And ECS will take care of the rest, replacing progressively all the old version by the new version. Or you can decide to play safe, and you decide that you want to decide by yourself how much percentage of traffic you want to route to the new service, and then you can leverage the weighted rules of Route 53 in order to decide what traffic you want to route to the new service. 5. Routing and scaling using ELB. Application load balancer is quite new, but he has a couple of advantages over the traditional elastic load balancer. The first one is the ability to have only one load balancer and being able to route your request to the correct service based on the request path. So here, for example, you can see that there is service1.mydomain.com, which is served by a certain couple of tasks of task 1, and you have server2.mydomain.com that is routed to another group of tasks. The second advantage of using ELB is the fact that when you want to scale out, you can spin up a couple of instances of the same task on the same instance, which is something that wasn't possible with ELB because you were stuck with only one instance because of the port that was already taken. 6 is the integration with AM roles. In terms of security, there is some flexibility here. So you had at first the ability to define an EC2 instance role in order to control the access to different Amazon services. But now there's another another level of IAM role, and it's at the level of the task itself. That means that you can decide that the task 1 has access to S3 and not to RDS, and task 2 has access to RDS and not S3, which is actually better in terms of security. 7, management of secrets. Secret management is quite hard and usually overlooked. The common use case is to inject your secrets using environment variables that are stored into task definition. It's already better than baking them into the Docker image, but it's still not very secure. And the reason for that is that everyone that has access to the EC2 instance or the Amazon console can have access to those secrets. A better way to manage those secrets was actually suggested by a recent blog from Amazon that I read a couple of weeks ago, and it's leveraging the EC2 parameter store, which is a key value store that is dedicated to manage secrets. The way it works is that, first of all, it's encrypting all the secrets using KMS with your own key, and it's only allowing to retrieve the secrets from the resources that are associated with the proper AM role, which is very convenient because you can then associate with your ECS task. You can associate the role to decrypt the secrets that you need in your configuration. 8, when you're using several microservices that are talking one to the other, you need service discovery at some point. You don't want to hard code the URL of all the services. So one way to achieve that very simply is by using Route 53. You just create a private zone, for example here star.cyber, and then services can talk with each other by just using Route 53 as a DNS resolver for all the internal services. 9th, autoscaling. When you have more and more load in production, you need autoscaling. Now here you have the flexibility to have autoscaling at the level of the ECS cluster itself or at the level of the task themselves, which is very good because you can define which one are the most required in terms of scaling. And finally, 10, Route 53 latency-based rule. So when you have multiple services, you want, and they talk one with each other, you want the ability to have the lowest latency. Now the problem is that sometimes those services are located in different regions. So one way we found to overcome this issue is to actually duplicate a service from region 1 to region 2, and then use Route 53 to have only one single external URL to the service, but we're using latency-based rules so that requests are routed to the nearest endpoint. In conclusion, we've been able to use ECS very successfully, and you can try to use it if you are running a lot of containers at scale. I hope that this talk has give you let's say an overview of the main advantage that you can leverage in the AWS system that we also decided to choose. And finally, as any successful companies, we're looking to hire. All the senior DevOps engineers in the room are welcome to join us. If you like challenges of scale and architecture, promise you won't be bored joining us. And that's it for me. Thank you very much.
Sorry. Well, we'll just use this now. So I think I think it's way more compelling to hear from people that are actually using this like at work every day. So rather than just hear from, oh, it's fine. Okay, well, it's fine. Everyone can feel free to come up and say they told me so after this. In any case, thank you very much to David for joining us. I think it's way more compelling to hear from people like David that use it at work every day, that have chosen it to build their architecture around it, rather than just hear me talk about it all the time. And I think he really hit on a lot of the kind of the compelling reasons why people are using like orchestration tools, is that there's a lot of benefits, right, from kind of decomposing your old monolith style architecture to all these microservices. But with the microservices comes a lot of trade-offs. So there's way more pieces to coordinate. There's way more deployments to coordinate. The pace of development can be much faster, and those are all really good things. But there's a lot more overhead that goes into working with something like that too. And what you should be looking for from your orchestration platform is the ability to kind of get these deployments out really fast, but also to kind of manage all of the pieces. So if you have 30 services, you have 40 services, you need something that's going to help you kind of manage all those, help you scale them, help you deploy them. And you should be able to customize that as much as you want, but also some things should just work out of the box. That is it. I will get you guys out on time. If you have any questions, we will both hang out up here for a little bit. Thank you very much.